Hi. Are you a software developer? Are you an aspiring Internet of Things developer? Do you have products and solutions and you want to attach those products and solutions to a developer ecosystem? Or maybe you have your own products and services and platforms and want to grow and build your own developer ecosystem. If you answered any of those questions with yes, well, then this session today is for you. Hi, my name is Lothar Schubert. I'm Director for Developer Relations here at GE Digital. Industrial Internet of Things, Building the Developer Ecosystem is the title of today's session, and I'm going to walk you through from our lessons learned, some of the best and some of the worst practices, as well about building a developer ecosystem. We'll talk about industrial internet, we'll talk about industrial internet technologies, we'll talk about Predix, which is GE's platform for the industrial internet, and we're going to talk about, well, developers and data scientists and how they are a part of that developer ecosystem. Before starting with the presentation, so a couple of words here, also with regards to the DevFest, which I'm honored to talk about today. Thank you all for attending the two-day conference. Hope you enjoyed it and you learned a lot. I had the opportunity also to dial into some of the fantastic sessions out there and learned quite a lot myself as well. This talk will be exactly the 100th DevFest session today. Maybe some of you had the chance to listen to all of them. Actually, it was not possible. Some were parallel, but I listened to many of them as well. All sessions are recorded, however, and are available on the platform for 2 months, also for replay as well. So make sure to catch those where you didn't have the chance quite yet. And where we received the slides for the talks, those slides will be available as well. With that, enjoy the presentation. I'm going to start now with Industrial Internet of Things, building the developer ecosystem. I'm going to share my screen for that. Let's start with the industrial IoT opportunity. And by all means, the opportunity is big. It's huge, actually. Estimates are that by 2020, which is not very far away, that there are going to be 50 billion connected devices. Those are billion with a B. Talk about devices on a fleet of assets. We talk about devices in an oil field, in a power plant, for example. We talk about healthcare equipment in other areas. 650 connected wells by BP. 1,800 engine fleets monitored with Delta. 1 million elevators in the commercial setting. IoT at scale we talk about here, for sure. And it creates a huge opportunity for software and services. So if you are a developer, if you are in the software industry, that's a good place to be in. 225 billion opportunity estimated by 2020. Ultimately, why we are in this business? So it's about outcome. It's about outcome for the industries. And you see some of the examples. Lixel, who's in Japan, it's a real big in the building sector, and reduce scheduling time by 66%. Rasgas, 2.5 million in outage savings, and Field Vision, $200 million in reduced unplanned downtime. We certainly talk about big numbers here, big opportunities, big savings from a financial perspective, but also huge opportunity to have an impact really in solving some of the world's biggest problems. Industrial internet plays in many different areas. You see aviation, power, utilities, healthcare, transportation, manufacturing, oil and gas, and also others such as intelligent buildings and smart cities and those kind of areas as well. We talk about huge opportunities in the area of aviation, for example. Every aircraft flight, every flight across the US has a potential to create 1 terabyte of data. Imagine what you can do with those data from sensors and from operational data as well. You can really inform pilots to fly their planes more economical, which can have a huge impact from a fuel savings perspective and also from an environmental perspective as well. Ensure reliability, on-time arrivals, that sort of things. And think about power, reduce unplanned downtime. There are massive investments into those big assets. and you have big commitments to customers such as us. And for the grid, you want to ensure grid stability and do it in an economical fashion. Healthcare, with image recognition, video analysis, huge opportunities, for example, for cancer detection in other areas as well. Rail, ensure on-time arrival, departure, and ensure cargo actually stays on rails. Believe it or not, if you cannot predict wind very effectively, there's a risk that some of those cargo trails will fall off the rail tracks. It's actually happening once in a while. So also the health and safety issues, think about those here. Manufacturing, cyber-physical systems, and really aligning from design to manufacturing to operations of specific industrial assets. The so-called digital thread is a huge opportunity, and provide feedback on an ongoing basis into manufacturing, into design as well, and so on and so on. Huge opportunities we talk about indeed. Typically, the impact on outcomes, we say it falls into areas such as predictive maintenance. Traditionally, assets have been run to failure. Well, when it breaks, that's the time you bring in the repair person and you fix it. Well, of course, that's not where you want to go. So people move to planned maintenance, similar to what you do with your car, for example, where you say you bring it in once a year for inspection or every 20,000 miles for inspection. But a much more effective way is to do predictive maintenance, because you can predict where the most economical time to schedule your maintenance as well, based on asset lifetime value, based on repair cost, based on need and uptime requirements, and based on parts availability for the matter as well. Results, less unplanned downtimes, millions of savings if you just have one less planned downtime, say for asset in oil and gas, less cost, better environment. At the heart of this notion of industrial internet is what is referred to as the digital twin. Digital twin, essentially think of it as a doppelganger, as a digital doppelganger of a physical asset. It's an analytic, it's a live analytic, which is fed from ongoing data streams, from sensors, and from knowledge about the data of the data model as well. Half of large industry companies will use digital twins, resulting in 10% improvements in effectiveness, is, for example, what the analyst firm Gartner is telling us. Let's dig a little bit into digital twins. Essentially, it's about taking a deeper understanding of physical assets in terms of understanding the asset model, about understanding the maintenance parameters of this asset, such as repairs, field services, things such as this, and having data feeds ongoing from sensors about the operation parameters, pressure, heat, those kind of things in addition, and running analytics. It's about applying machine learning and deep learning, for that matter, to massive amounts of data. This data, such as time series data that you see in the upper right-hand side, but also images and video feeds and service records, for the matter, as well. Develop those models using supervised learning and feature engineering, for example, material science might creep in there as well. And then use massive computing resources, of course, cloud, elasticity, CPUs, but also GPUs, graphical processing units, to train models, run inference, apply to the data in the cloud, and really drive better understanding and better prediction about when to take action, for example. How those digital twins typically are materialized, it's via applications. In the case of GE, we provide applications such as for asset performance management. It's about asset monitoring and diagnostics, field services management, as well, and other type of applications. At the core is those digital twins, which again are materialized and built and operated using a platform. That's where Predix comes in, which is GE's platform of the industrial internet. The platform to build and operate those digital twins to feed and support the applications. We really want to talk today about developers. To give the example of the Predix developer community, the dev community has been growing to now 33,000 and more committed developers in their platform. Those developers really spans a whole gamut from front-end developers to back-end developers, full-stack developers, data scientists, data engineers and data architects, cybersecurity specialists, embedded software developers, but also industrial and controls engineers, people who worked in the past and keep working in things areas such as controls and use terms such as SCADA systems and programming and logical controls and industrial PCs on an oil field, for example, in a transportation setting, in manufacturing, on a wind farm, or things such as this. We have experienced a quite significant growth over the last couple of years since Predix in particular is in general availability since 2 years. Now, why do we care about developers? What is really so significant about developers in industrial Internet of Things or in general? Actually, fairly interesting, at a recent C-level, executive level conference called Minds Machines in San Francisco 2 weeks ago, our CEO, John Flannery, was quoted saying, every employee will have basic understanding of coding. Every job will involve software skills. Now, what does it mean? Of course, it doesn't mean that every business person is going to be a developer, but we see also the emergence of notion of what Gartner, for example, refers to as citizen developers. So more and more software skills are creeping into the general workforce as well, and are actually required for that matter as well. In particular, in the industrial space, we see in the control space also a little bit of a problem of an aging workforce there as well. And we need to bring in new technologies in the space as well, also for people who are not necessarily software experts. So 4GLs, for example, are really critical, or graphical programming environments in this area as well. Developers are the new kingmakers. Developers such as you, if you're developers, are really who drive innovation in that space. You work with new technologies such as Spark or blockchain or other frameworks as well to really drive differentiating innovation very rapidly. There's a book written, it's the New Kingmakers, GE co-published together with Redmonk, a developer analyst firm, and together with Stephen Grady. I encourage you to download that book for yourself as well. Let's talk about building the developer ecosystem. Let's assume you have a product, you have a service, and you want to build a developer tribe around this, or you want to join an existing developer ecosystem. What do developers really care about? I want to talk about this here as the developer hierarchy of need. In a way, similar to what the Maslow hierarchy of needs is for humans. They need physiology, they need safety and love and those things. Well, for developer, well, they need those things as well, but they need 5 things. They need a useful product. That's the beginning, that's the baseline. Product has to be there, has to be working in a reasonable state, and it has to be usable. So useful. You need easy access to the product as well. Low burden to access. And you need the tools and tutorials to find it, actually get started with this. But you also want to connect. You want to connect with an active community of like-minded minds, sharing a common vision, such as coding for the industrial internet. And you want a career path. It's fun, it's interesting to work in industrial internet, and you solve some of the hardest problems, and you actually do greater good in a way as well. By, for example, solving transportation challenges, by helping to solve environmental challenges, by helping to solve water shortage issues. But ultimately, there has to be a solid career path behind it as well. All right, you ready for the journey? Let's walk through those 5 steps. Need number 1, it's a useful product. And I promise you that is the only and most pitchy slides that I have here. I'm going to talk about Predix, but I think many of the concepts, even if you're not committed to Predix itself. A platform for the industrial internet needs to live in both the cloud and on the edge. That is a key differentiator of it. So we talk about an edge to cloud platform. Edge means this is software that runs actually physically on site where you have your operations. You might be familiar from the consumer space with the Raspberry Pi, Arduino. In a way, similar aspects, but taken to a larger extreme here. in the industrial world. But that's not all. You also have the cloud as well, and you leverage the scale and cost effectiveness and availability of the cloud as well. You need a platform which is built for the industrial internet. Think about where you have those sensors. They're sitting underground in an oil well where temperatures can fluctuate a lot and high pressures can persist. Raspberry Pi typically won't do it in the setting. As it can be on move, such as a train or a plane where the bandwidth might not necessarily be always ensured. Or sensors might be spread across a large network of nodes, such as power grid, or think about street lamps, for example. All of the street lamps have sensors, by the way, those days. So at the edge, you deal with very specific requirements, often dealing with latency, and you need real-time processing if you deal with assets. Those could be environmental, health, and safety hazards if you do not work in real-time fashion. So edge processing is critical. You also don't have the bandwidth necessarily. I think you're in a mining scenario, for example, or you're in an oil rig, or you're in a moving train. Connectivity could be an issue in this area, and security compliance is very critical. There are governmental, there are industry-specific security and compliance requirements where it says some of the data you actually cannot take out from your country or from your specific area. So edge is critical, but so is the cloud as well. We deal with big data, we connect multiple edge systems, we deal with large workloads. You want to use the scale and availability and elasticity of the cloud, and you want to integrate with enterprise systems, such as supply chain management systems, such as your Oracle and SAPs, such as your material requirements planning systems or finance systems as well. So a platform really needs to be built for both worlds. It needs to have a like on the edge, a like on the cloud. It needs to connect both worlds. It needs to run data management and analytics and deep learning across both the edge and the cloud as well. That's in our case where Predix comes into place. That is the Predix platform. I want to just very rapidly jump in a quick demo of the platform. So that's what you find here. I showed you some of the architectural elements. We won't go in deep detail here, but in the Predix.io, you can check it out for yourself. You see those elements here exposed via what we call a services directory. You find edge software and edge services, software to manage those edge devices, embedded software to deploy against those embedded devices. But you find data management as well. You find application services and analytic frameworks. Security is a big aspect. So managing security and encryption and access control, very critical in the industrial world. You don't want anybody to tamper with the national grid, for example. Mobile services. In fact, we very recently also partnered up with Apple on an iOS Swift developer kit as well, which is available on the platform as well. By mobile, well, think about you're a field worker and you are in a setting where you inspect a rail, for example. You want to take notes, and you might have to do it in an offline fashion, for the matter as well, in your on your mobile device. That's where the Predix developer kit comes into play. So we talked about the need for a useful platform, but you also want access. You want quick access as a developers. And that was actually one of the biggest feedback that we got. So here's some of the best and the worst lessons here. We thought, well, it might be okay to have a great platform here, and then contact us. Not so. The most required feature, as you can tell here from 2016, was please give us a freemium pricing model for Predix. Give us a free tier where we can tinker with Predix. And ideally, developers told us they don't want just a 30-day trial because, well, they have other jobs to do as well. And once they get started with Predix, then the time might be over already. Just give us an unlimited free tier for the platform. Well, it's important, of course, to listen to your customers. And that's why G also decided we launched Predix now with a sign up for free. There's actually a true free tier available on the platform now as well. Well, just getting a free tier is not sufficient. To get easy access, in particular in this edge to cloud scenario here, we also realized with all the different technologies, data management and analytics and security and connectivity and embedded edge software, this needs to be packaged. It needs to be made simple for developers to get their arms around it. That's where GE decided. We teamed up with Intel Corporation, and we recently showed at our conference 2 weeks ago the Predix developer kit. It's a very new bundle of hardware and software, which is really pulled together with the specific purpose to make the getting started easy as possible for software developer. With the developer kit, it's easy to connect and develop the first purpose-built solutions with Predix as well. The Predix developer kit, I want to spend a few minutes on this one here. So here's how we built it here. We took, put in a box here, we took a gateway device. In this case, it's an Intel NUC device, which uses an add-on processor and 4 gig of flash. Of course, with all the cables, wiring, and all the good stuff here, but also includes a sensor kit, and which has a vibration sensor, has a light sensor, temperature sensor, that sort of thing, and also has an analog digital converter in form of an Arduino as well. But that's not all of it. It also has software pre-installed already, specifically what we refer to as a Predix machine. It's kind of an edge software which is running out of the box on this. And it literally takes you, if you've done it a few times at least, it takes you 5 minutes to unpack the kit, connect all the devices, 5 minutes to enter an IP address of your network, and launch a client console, which is running actually on the device itself. So you don't need another, technically you don't need another PC, just you would need a monitor for that one. And once you're done with this, it's another 5 minutes to say, I want to connect now to the Predix cloud, and I want to start streaming the data. And then you actually have an application that you can expand and grow from there to build very rapidly your own IoT, industrial IoT application. Walking through the steps, here's how this would present itself. Once you launch it, you see which sensors you have up and running. Again, that's still running on the device itself. And it also has Node-RED in there. It's an open source software and allows you via drag and drop to very easily, very rapidly connect additional sensors as well. And that's really a quick drag and drop approach, makes it really, really easy for you. And once you've done this, you say, you know what? Now I'm ready. I want to send my data to the cloud, and off you go. And data are getting into the Predix cloud, where you then can take those data and you can actually build applications such as the sample app that we built, which is actually an aircraft, airline fuel savings and noise abatement application for aviation sector. Well, it's not connected quite to aircraft engines here. It's connected really to those sensors that you have, but you can imagine we're building a simple monitoring and diagnostics and optimization solutions in a fairly short period of time yourself using Predix and the GE Intel developer kit out of the box. To make it easy for developers, we also put the code on GitHub. That's certainly also best practice. Make it available for developers. GitHub is the place to go those days. Make sure it's on an open source license, and we have to work quite a lot here with also our corporate lawyers internally. As many can imagine, GE is very big on compliance and those kind of things for many of the right reasons here, of course. But we were able to publish this on an open source license as well, so it can be taken with anybody, can be cloned and used and extended from there as well. We talked about the need for use of platform for easy access. Next one is about tools and tutorials. Developers want guidance, they want help, they want resources to work with the technology. Now, industrial internet is a pretty new area for many folks here, even if they're coming from many years of software development and worked in digital marketplaces, work in consumer or commercial software, maybe in finance, maybe in advertisement, and other areas as well. Industrial, it's its own beast, if you want. So it's good to get grounded in industrial IoT. We wrote a book, Industrial Internet of Things. It's available free. It's a Wiley book, but a free version is available for you, a free ebook copy. Here's a link. You can find it there. One of our developer advocates teamed up here with a broad community of industrial experts to write a book. It will follow the story of Ralph. It's actually written quite in an entertaining way. Ralph is an industrial controls engineer who's working in an industrial setting. And we follow Ralph around as he explains to us the industrial Internet of Things and as he learns how to use it. The book also will come with a digital complement of a tutorial where you can follow Ralph along and actually can deploy simple apps yourself. We will cover edge to cloud, IIoT architecture, the notion of the digital twin, and how to design and build applications using Predix, but also low-code development environments as well. You want to provide Predix resources, and at this point here, or developer resources, I want to give you a flavor of what we're doing specifically with Predix. So we looked at the platform in general. It's when it presents itself and you go into Predix.io, that's where you can sign up. You can create your free account. Of course, you find more about how to use the platform. It shows you case studies, and I encourage you to visit it as well. I got a few questions already about what are good case studies for the industrial internet. So here are some really technical case studies for manufacturing, for landing gear in an aircraft setting, for asset analytics, thermal imaging, and wind farm as well. And each and every of those also shows actually how those applications have been built. In some areas, you actually find code as well and tells you how to clone and build those applications for yourself as well. You'll find resources as well and sample applications. So there's a sample applications that you can run for yourself. I hope I didn't time out quite yet. Let me refresh. That's a sample application for, of course, it's happened. Always happens in life, right? And it's a sample application monitoring diagnostic. It's a live monitoring diagnostic application. And the code is available on GitHub as well, so you can clone it and take it from there. And once you have an account you deployed for by yourself, you can actually sign in the console. You can see the building blocks. Remember the services we saw before? Asset, time series, analytics. Those are the building blocks that you have as part of your platform. I want to come back to this later, but let me switch back to the presentation. Now, talking about toolkit here, it's important to stay in touch with what developers really work on and tools of the trade that developers really like. Some people ask me, okay, what languages do you recommend? What frameworks do you recommend? And look, there are many frameworks, there are many languages out there, and sometimes it's almost a religious debate. What are the right language and the right frameworks? There's quite some research out there. If you go, for example, Stack Overflow, they did an excellent online free, can work with other forks such as /data or Events Data as well, who have in-depth research specifically for IoT. You find many languages, but you also find some interesting patterns. For example, you find Python and JavaScript and Node.js growing very rapidly. In particular, Python, very interesting as well, because if you look at machine learning and deep learning, Python lends itself really well, as Python R, for example, for the space. So we decided, we paid attention, we worked with some students, for example, in a recent hackathon, and 7 out of 10 students said they're working with Python, which we find very interesting. So we said, you know what, really need to build a developer kit for Python as well, which is now available. Again, it's available open source. Make sure you pay attention to this. Make it available, in this case, using pip install. So where Python wanted, there where Python developers already hang out, make sure your developer kit is available there as well, and you can download it for free. Now, when we launched this kit, we also said, let's provide it together with an application. So there's a sample application we launched as well, and you see it's actually a digital volcano application. And that's actually an interesting story that I want to share with you. When we were about to build the Python application, we were thinking, what should be the sample application that we want to build that actually is interesting, fun, but also half serious. It's industrial internet, of course, area that we work with. And we stumbled across a project. At this time, GE actually had been approached by the government of Nicaragua and by some researchers to research volcano eruptions. And we started talking and said, you know, that would be actually a very useful and very interesting project to work on. And voila, we launched the digital volcano. So a little bit about this. Nicaragua has a major volcano. It's an active volcano, actually. It's a Masaya. It's an active volcano lake. And we said, let's instrument that volcano, which was a challenge by itself. The team needed to create a zip line, essentially, over a volcano lake, 1,000 feet above the lake, 1,000 degrees Celsius. There's some really cool videos out there that I encourage you to watch as well. And they were then using the zip lines and those asbestos suits that you see from firefighters to install sensors. 80 or so wireless sensors were installed and repositioned: pressure, tremors, humidity levels, different types of gases which are measured, to really put a digital early warning system in place to tell when there's an eruption, to avoid explosive eruptions or be aware of explosive eruptions and amounts of ash which can settle on roofs and make homes to collapse or cause traffic accidents, to aware of potential air contamination with gases and things such as this. It's an open source project. We made the data available and we built the reference app. And it was another quick anecdote here. The sensors are no longer there. They melted away after 30 days. Even so, they were in this really, really solid industrial cases there. Well, 1,000 degrees Celsius, you can imagine that gets pretty awfully hot there, even if you're a little bit away from this sensors, but not before capturing lots of data. This, by the way, is a team, and you also find the developer there. So that's a Predix developer, one of our Predix developer advocates, one of the community members of the Predix community being actually part of this expedition, and he connected with another team of 10 developers behind the scenes to build the application. So it was a very engaging project. It's there to help the greater good. It was fun as well, and really helped to build and pull the community together. It also received lots of social media attention for the matter as well. Check it out on YouTube, etc. Talk about the developer community. So that is number 4 that I want to talk about. An active developer community, find a platform to connect different community members with each other and with a common purpose. It's really what building a developer community is about. How you can make it happen, how we are making it happen, is having a committed team of people who are really both left and right-brained, and that's a very rare breed sometimes to find. You want to work with people who are excellent developers, really good in their specific domain, from a developer, from machine learning, from a cyber security, from an architecture perspective, but also who are good or even great communicators who love to engage with their communities, be it in the region, be it in their industrial domain, be it in their organization as well. So we built this domain of Predix Builder influencers, who, by the way, most of them are not paid by us. They do this because they are passionate about it, about advancing industrial internet and working on the Predix platform. And they carry, if you want, the mission into the greater market. We do have a few evangelists, or I rather want to use the term advocates, which are actually salaried employees. They evangelize Predix. I would rather say they're advocates I like this term better, of the developers, because they assist those developers, they cater to the needs, they listen to the developers, but also they carry developer requirements back into the organization, which is very, very critical about developer community as well. We engage with the community running what we call the machine shops, using the developer kits, and we run quite a few hackathons and appathons as well. We meet with those developers at those appathons, and here is an example of an appathon that we were just running 2 weeks ago at Minds Machines. We ran together with Intel and our GE Ecomagination on the notion of sustainability. We ran 3 tracks: enterprise track, startup track, and also with GE internal teams participating as well. Over 48 hours, just 48 hours, is very impressive, quite amazing actually, what people build there for integrated power management, parking optimization, to demand response systems, emission and combustion, dashboards and control systems. And they build it really in a very short period of time. No, those of course are prototypes. Those are not industrial type of applications, but it's very promising, the level of innovation that you find with hackathons. Hackathons can drive multiple purposes there. It can be a great source of innovation. We actually had a couple of venture firms also participating, being judges. And some of those teams are now interviewing really for sponsorship, for accelerators and things such as this. It can also be a great source of feedback for the product organization. When you have a new API and when you get feedback for this, it can be an excellent source of talent acquisition as well. It's a fight for the best talent out there. Hackathons are a great way to engage with the community as well. And we see great things coming out of those hackathons. Here is an example of what we ran with the hackathon last year, which used, we had, sorry, yes, I'm on the right screen here. That was for automated rail inspection in this area. So that was a hackathon which ran for 30 days. So ran a little bit longer there. Teams had more time to prepare and in depth look at the business case and build a really solid case. In this case, they worked with high definition cameras mounted to train locomotives. And so we worked with our rail group, for example, there, and they used image recognition. They deployed machine learning neural networks to this to identify obstruction, for example, on rails, to define defects on the rails. Think about the savings there. In the past, in the old days, you had actually people driving out there with trucks and inspect those rails. Of course, there are also drones and other ways and cameras that can be deployed right now, but they deployed it on the locomotives, and you can do it on an ongoing basis as well. That was quite amazing and actually found its way also now into a commercial product. The team, actually, they also gave a layman's version of this, which is available on Predix.io blogs together with the code as well. So they deployed those machine and deep learning algorithms there using also frameworks in this case, such as Caffe and TensorFlow and other frameworks, and to build a Python application to on Predix to do for image recognition. I uploaded this picture, and I think it still needs a little bit of training there. It's pretty good here. I think what it says in the back, it's sheep, 66%, that's a sheep. I think that's a cow, actually. But by and large, it works actually pretty well, even with very little training here. So those are hackathons, and you can see it's fun. It's fun to engage with those developer communities. We do it around the world here, and using those Predix Builder influencers and package developer kits, able to run those hackathons also at scale anywhere in the world. We run it in France, we run it in Paris, in Shanghai, in Berlin. We run it in Africa as well here. And so that's really, really a great way to engage with your developer community. Now, talking about career path. ultimately, that's also where the rubber hits the roads. We all need to feed our families, or all need having a solid career path behind it. What are the opportunities of Industrial Internet of Things? We mentioned it before. It's a $225 billion opportunity for products and services. How can you monetize it if you are a developer or a startup, for the matter? Well, multiple different ways. You can, of course, innovate with software in the marketplace. There are existing marketplaces, such as the Predix catalog, where there's an opportunity to promote and sell and monetize your software, services, your applications. There is a venture capital community out there, G Ventures in the case of G, but there's many, many other venture firms out there, and IoT and machine learning is a very hot sector to go into as well. So those are opportunities to look into. Get certified. If you are more the person who don't want to start your own business, but you're a great architect, you're a great talented developer, and you want to join maybe a large or small consulting firm or work for one of those industrial firms, demonstrate that you have the skills. Look for certification options in your area as well. And I had to make the pitch here. G is hiring as well. Certainly encourage you to visit the website for talentgcareers.com digital as well. Read more. Just to come back to it here, find my blog for the new Kingmakers. Read the book. It's available as a free download. And certainly would welcome your feedback on that as well. And finally, a couple of links that I have for you as well here, where you can find more information. Industrial Internet for Developers, the ebook, the new Kingmakers book about how trends developers conquer the world. Go to the Predix.io website and create your free Predix trial account, or free tier account for the matter. Looking for more industrial examples and case studies? Go to Digital Industries. Interested to becoming a partner? Join the partner ecosystem, Digital Partners. Or security, actually, I know is very big at the DevFest here as well. Visit resources for secure development lifecycle for Predix or for industrial internet in general, for that matter. With this, that brings me to the end of my presentation, and I want to switch to the Q&A. So a couple of questions which come in here. Let me take it from the bottom and work myself up. Please share the link to the slides of the presentation. So recording is going to be available after that presentation as well. Sorry, I missed how to get the hands on G and Intel Developer Kit. Actually, I did not miss it, and I didn't share it with you. So the Developer Kit is actually available currently only via community events, which are provided by G and Intel. So it's hackathons and hackathons, it's workshops. It's not a commercial offering quite yet that you can just buy or receive somewhere. So you need to actually work with us to get the kit. Find us, go to the Predix.io community page, find an hackathon, a hackathon, find workshops or a training, and that's where you'll find the developer kit. If you don't want to write for yourself and you want to do it yourself, there are actually instructions on the Predix.io website for tutorials and guides, which also show you how you can essentially build your own kit using an Raspberry Pi or Intel Edison or something like this. The Predix is not available in Russia or in China. Anybody knows why and when will it be available? Yeah, that is correct. And it's not that we don't like our Russian and Chinese developers. So it's a very important market both for industrial internet and for development, right? China, third largest developer market in the world. It really has to do more some of the compliance requirements, and specifically for I don't want to go into this specifically here, but there's lots of compliance requirements we need to work through on making industrial internet applications available in different regions. So it's just not available there. Almost my apologies here for that one, but we're working on this. We understand it's an important market for us, and please stay tuned for it as well. URL for Predix IO kit, as mentioned, it's not available for purchase. Go to the website where you will either go for the community website on Predix IO or for the good tutorials where you can find more information. Wow, lots of question about the developer kit. You can find out if a browser is compatible. I'm not sure what this. Great Chrome that works. Okay, it looks like there are some issues with the website as well. Okay, let's see, maybe a few of the part applications that we find there were some questions that I had about smart cities and what's the role of industrial internet and IoT for smart cities. So that's certainly a big area as well. Cities are increasingly investing into those digital initiatives as well. You find with limited budgets and the need to do more is the public sector is increasingly teaming up with the private sector to provide services and provide critical infrastructure to its citizens as well. And a really effective way the government and city councils found is doing this using APIs, is for providing data feeds by open sourcing data and functions as well to work with the private sector as well to develop solutions, for example, for parking, for transportation, for healthcare, and things such as that as well. Okay, here's a question coming in about industries. Which industries do you see as the fastest growing? Are you currently doing industry-specific developer events for Predix? Yes. So industry growing, we see it a little bit across the board, right? So it's not one or two specifics that I can point out there. We see lots of interest where we also have been running quite a few industry-specific events, developer events in actually the smart cities area. You can also go online. There's what we call the City IQ platform, and we've been running quite a few developer events. Joined with this team, also hackathons, running a university hackathon as well. That's about to kick off right now with Cal State, with multiple campuses that specifically works with smart cities. At least that's what the plans are right now. So that has gained quite a lot of traction. But it's really not just limited to this here. We see power industry being really on the front running as well to instrument sometimes equipment which has been around for 25 years or so. Right? Those big turbines are not something you just throw away and buy a new one. So equipping those assets with sensors and tapping into those control systems, build those digital twins is really, but healthcare is really critical as well. Transportation, so that's really not one that sticks out. Manufacturing is actually huge as well, and probably has been on the front running. Also, if you look in other parts of the world, in Europe, for example, in Germany, Industry 4.0, it's about cyber physical systems, it's about robotics, it's a big part, and autonomous production systems. Again, thank you very much for your attention. Hope you enjoyed this session. Hope you enjoyed the DevFest, over 100, or in total 100 sessions actually. And again, sessions are recorded. They're going to be available for the next 2 months for you to watch offline as well.